Good.
Yes. And name it. Now the question is, draw the structure of the third member of the alkane homologous series and name it. Now alkanes are hydrocarbons which are made up of only single covalent and they have the following general formula: CmH2n plus 2. What's the general formula? CmH2n plus 2. Whereby n refers to the number of carbon atoms in the homologous series. So n is equals to 1, 2, 3, and so on. So the first member of the alkane homologous series will be having 1 carbon atom. The second member will be having 2 carbon atoms. The third member will be having how many carbon atoms? 3. So using this general formula, we can get the molecular formula, whereby we take n to be how many? 3. Are we together? Yes. So it will be what? C n. What do you write? 3. H 2n. 2 times 3. 6. Plus 2. 8. So it is C3H8. Are we together to that point?
Yes.
So you now draw the open structure showing all the bonds and all hydrogens. How many carbon atoms will be in the structure? 3. How many hydrogens? 8. So you have it like this: 1. How many carbon atoms have I drawn?
3.
3. Now for each carbon atom, we should be having how many covalent bonds surrounding it? 4. Each carbon must be surrounded by how many covalent bonds? 4. So we have 1, 2, 3, 4. So this carbon, 1, 2, 3, 4. This other carbon, 1, 2, 3, 4. I hope you are keen enough to realize that each carbon, the covalent bond has not touched the carbon atom. Are we together? Yes. So you also make sure that the covalent bond does not touch the hydrogen. Are we together? Yes. So you write hydrogen, 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 hydrogen. Are we together? Yes. Now the third member, the prefix for 3 is pro, and the suffix will remain a. So the name is propane, pro, which is the prefix for 3, and then ane to indicate that it is an alkane, having single covalent bonds alone. So the first structure here is what? The molecular formula. So this is molecular that is the molecular formula. This is the open structural formula. Okay? And then, what you're having here is the general formula of the alkane homologous series. I hope you are done. Magata?
Yeah.
The next question. When the alkane hexane is heated to high temperature, one of the products is ed. Write the equation for the reaction. What's the name of the alkane? Hexane. Okay. Now, hex is the prefix for how many carbon atoms? 6. So because of the prefix hex, then we know that alkane will be having how many carbon atoms? 6. And then the suffix is A, indicating that we only have single covalent bonds in the structure. Are you together? Single covalent bonds alone? Alone. So we have the alkane. So we still remember the general formula, which is CnH2n plus 2. Are we together? So if n is equals to 6, what will be the molecular formula? Let us use the general formula C6H2n. 2 times 6, 12, plus 2, 14. So that alkane will be having the molecular formula, which is C6H14. Are we together? Yes. Now, this is a solid. We are hitting it strongly. When we hit strongly, one of the products is what? Ethene. So, ethene, okay? What is the prefix? Eth. What is the prefix? Eth. Eth is the prefix for how many carbon atoms in the structure? 2. Okay, so you write, so the number of carbon atoms are how many? 2. And then the suffix is in. The suffix is in. That suffix in indicates that we have at least one carbon double bond. So this one shows that we have carbon double bond, which is at least one. Are we together? Lastly, we have we should look at the general formula for alkenes, which is CnH2n. CnH2n, where n is equals to 2. Go pamoja. So now we have Cn, which is C2H2n. 2 times 2, 4. So ethene is C2H4. So that is one of the products here, which is C2H4. It is a gas. So we write gas like that. Plus another product. How will we get the other product? We take the molecular formula of hexane, we subtract the molecular formula of hexene. Come in. Let us subtract carbon. Let's start with hydrogen. 14 minus 4. 14 minus 4. 10. So it means hydrogens are 10. And then carbon. 6 minus 2. 4. So the product will be ethene and another product with the formula C4H10. So this one is ethene and this is butane. It conforms to the general formula for alkanes. C4, N is equals to 4. Are we together? Yes. C4H will be 2 times 4. 8 plus 2?
10.
Which is this formula. So this is an alkane. So we write here gas. So that is the formula. Let us do the last question related to that. And okay, name the process described in B. which process has been shown by this equation here? C6H14, C2H4 plus C4H10. That is what? Cracking. Are we together? So the general term is cracking. But which type of cracking is it? We are cracking using heat. Are we together? So to show that we are cracking using heat, you start with the word thermal, showing that we are actually cracking using high temperature. So the right response there, this process refers to thermal cracking. Okay? We have not used a catalyst. Otherwise, if there was a catalyst there, it could have been catalytic cracking. How many types of cracking are there? There are two. Thermal cracking and catalytic cracking.
Okay.
Done.